Hello, and welcome to this presentation by Colin Quiring for the Project Virtual Conference 2015. This is the Eli Critical Chain, not Path, Portfolios and Microsoft Project presentation. First thing we want to do, of course, is thank all of our sponsors. Without them, this would be a much tougher event. So, real quick introduction of who I'm with. I'm with EPM Strategy. And EPM Strategy is a project management and Microsoft project-centric organization. We do work with other technologies, but mostly Microsoft Project, and are certified in Microsoft Project. And we also help organizations with their project management needs, regardless of their technology. And as it states there, our goal is to improve project management every day. So if we get a little better every day for us and our clients, that's wonderful. So, and then as it says there, our expertise is in the organizational change management, project technologies, and the project program and portfolio management, which, of course, this presentation is about portfolio management and critical chain. So who am I? I'm Colin Quiring, and I have over 20 years of experience in several different industries doing project management and having worked with many, many versions of Microsoft Project as a result of that. I also authored the book, Mastering Resource Management Using Microsoft Project and Project Server 2010. So we've used a lot of Microsoft over the years, particularly with resources. And knowing that this is an international presentation, I'll just real quick cover what those certifications are. MBA is a Master's in Business. PMP, I would expect most people to know, it's the Project Management Professional from the PMI organization. MCT for Certified Trainer from Microsoft. MCTS for the Microsoft Certified Technical Specialist, which in my case is the Microsoft Project Server, Project Professional, and just all the project ones that you can get. Also have the OPM 3 from PMI, which is the certification for organizational project management, and then the CERM certification from the APIX organization, which is certified in integrated resource management. And I have more of my information near the end of the deck. The first thing I want to cover to go over with everyone and make sure that we all kind of have the same level set is the definitions and some of the concepts that I'm going to be talking about. So that way things make a little more sense coming up. So basically I want to explain that some of these terms, and again, emphasize the fact that this is going to be about critical chain, not just critical path. And that is a little bit different, and that critical chain comes from the Eli Goldratt. Well, I don't know if it came from him as much as he popularized it. The critical chain, he has a couple different books out there about critical chain, and particularly in this case, how it results and affects resources and how resources affect critical chain. And we'll get more into the explanation as we go through some of these slides. So I don't have that many slides, but I just want to make sure we're all on the same page. And being on the same page, I just want to make sure we cover some of these definitions and exactly what I'm trying to get to on the demonstration. Otherwise, it doesn't make as much sense. And part of these next few slides may feel a little disjointed, but these are kind of some of the puzzle pieces. And you might know what some of these things are already, but I just want to make sure we're all, like I say, on the same starting point. So for this demonstration and all these demonstrations, I'll do about 3 or 4, we're going to use the resource critical chain. There's other kinds of critical chain mindset that we could be having, but I'm going to use resource, and that's part of the reason is because that's what's built into Microsoft already. Then I'm going to take it up one level and do resource critical chain along with the priority, in my demonstrations, the priority of the schedule. We could do resource priority and task priority as well. That was not part of this demo, but once you see this, you can probably figure out how that would work. For critical chain, though, to work properly in any of those scenarios, we should use baselines. I have baselines in these. If you don't have baselines, how do you know what happened when you actually hit the button to make things move? So it's not that it's required, but you should have a baseline so you know where it was before you started messing with it. You also need to have an understanding of task types. If you don't know the difference between the fixed duration, fixed work, fixed units, that's going to affect how this works. And fixed duration versus fixed work definitely will swing the critical chain and leveling and all the other things that we're going to be trying to do. You also need to have a shared resource. I am demonstrating across on a server environment across multiple projects for these resources that are shared amongst projects. So having a resource pool or an enterprise resource pool with the server is required to do this as well. Otherwise, critical chain by definition, we'll get to a little bit more, but critical chain by definition is about the whole and not just a single schedule. And you should also use calendars. The default is fine, but everybody should be on a calendar. For example, what if you have a resource that has a certain time period off or works part-time or doesn't work the standard calendar? Then you could definitely affect, again, how the resource critical chain and what's results. You also need assignments. If we don't have, this is the resource critical chain. If we don't have resources on tasks, then we don't have assignments, and then we kind of don't really have much good there. And we also need to have predecessor and successor relationships. If we don't have predecessors, then nothing's going to move because everything all starts at the same time. Or conversely, everything will move, but it won't move in the way we expect. And then this is a really important one. No constraints would be great. Very, very few task constraints would be great. Even one task constraint, that's what I'm referring to here, could render the results invalid because you'll end up kind of running into this constraint and the system will work. I'm not saying the system doesn't work. The system will work fine, but what's going to happen is it's going to render the results something that we just look at and go, no, that doesn't make any sense. So these are kind of some of the requirements. The regular update cycle, making sure that we are updating our schedules routinely. Otherwise, what are we updating, right? We recommend at EPM Strategy, we recommend once a week as the standard. We know that some of our clients do more than once a week and some do once every couple weeks. But the norm is once a week, and that's kind of the standard update cycle. Because you have to have an update cycle because the data must be current and relevant, right? We have to have up-to-date schedules. This is an important effect that we're trying to sustain here, and in the demo you'll see that if we had bad data, then our effects of trying to set the critical chain wouldn't work as well. So just, again, definitional. This is straight out of PMBOK. Project management is the application of knowledge, skills, tools, and techniques for projects. Program management is, for the program. And then what we're going to be dealing with for this is what we're trying to get to here is a portfolio. One or more one portfolio, but multiple, in this example, multiple projects. So we're doing critical chain across the entire portfolio in this case, all right? So I just wanted to clarify that. And then just a quick clarification again of what an assignment is. It's a resource on a task, all right? Again, just making sure we're all using the same verbiage. All right, a buffer. Okay, a buffer, again, straight out of the PMBOK version 5. It's normally we consider it a time delay, right? We just have some reserve time, whether it's its own task or we have every task out there that has additional time on it. However we do it, it's common, and we're going to get a lot more detail about this here in a minute, but it's common to have a buffer, so we need to know what that word means when I'm getting to some of these examples. So critical chain is all about that buffer and where that buffer is, because normally people will buffer their time estimates on each task, right? You go to someone, you say, how long is this going to take you? They say 10 days. In their head, they might be, all kinds of reasons why they're saying 10 days, but they know that if that was the only thing they had to work on, the only thing they were doing, they might do it in 1, 2, 3 days, right? But of course, they're buffering in their time estimate. They're buffering everything else they're doing. They're buffering for risks in their heads, right? That they They may have things happen or think they're going to have things happen, or they're not sure exactly what you're asking for, and so they're adding buffer to each task. In the critical chain world, in the critical chain environment, the buffer is on the entire project. And this is a fairly significant difference. And we have some diagrams here and a couple screens to kind of go over this. But this is something to keep in the back of your mind, that normally people will buffer on each task and a critical chain. Because we're talking about the portfolio, we're also talking about each entire project, not just each task. So let's talk a little bit about that buffer, and what we normally call it is multitasking. So multitasking is what CriticalChain takes into account and can be dramatically reduced and or eliminated. So for those of you that are rolling your eyes, yeah, it can be. I mean, this CriticalChain is not for the lighthearted, I'll admit that. But it is something that will definitely reduce a task level immediately. It reduces or eliminates buffer. It puts it on the project level. But then what happens is, as we get better and as we multiple schedule, like do multiple schedules simultaneously, then what happens is we can reduce and reduce and reduce the buffer, because we end up with less multitasking. So a normal situation, normal organization, right? Multitasking is just part of routine business. Everyone works on 10 things at once. Well, let me give you a quick example, and this is straight out of Eli Goldratt's book about CriticalChain. Well, I made up the example a little bit to make it a little more pertinent to us, but this is the concept is straight out of Eli Goldratt's book. So in this example, we have just one resource, and on each of 3 separate projects, this resource has a task. So on project 1, there's task 1. On project 2, task 2. Project 3, task 3, the P3, T3. Okay? Each task takes 10 days to complete. So for this resource, let's just say this resource is only working on this one thing. The total time to finish these 3 tasks on 3 projects is 30 days, right? And it looks like this, okay? Very simple. Does task 1 on project 1, takes 10 days. Project 2, task 2, takes 10 days. Project 3, task 3 takes 10 days, right? 30 days, goes one to the other to the other. And that would be a great way to do that. So as we've said, it takes 30 days to do all these tasks. It takes 10 days from start to finish for each task. So let's think about this though. What if these 3 different projects and the different tasks were in order of priority by project? That this resource should have done P1, T1 first, then P2, T2, right? What if that's the way it's supposed to be? And you have, let's say we have 3 different project managers. So let's say we have 3 different project managers. What happens in the real world? Well, each project manager says, start my stuff, start my stuff, start my stuff. My stuff's important, right? So what does this resource do? Well, that's what this diagram shows. They start working on project 1, task 1, and let's say they do half the work, just to make my diagram pretty. They do half the work, 5 days. Then they start the next one, because that way it looks like for P2 and P3, those project managers say, woo, finally, we got it started instead of waiting. And they feel good, right? And we've multitasking. We're doing wonderful things here. So the resource does that. Well, look what happens. We still have the same 30 days, right? But each individual task takes twice as long to get done. So now, task 1 for project 1 takes 20 days instead of just 10. There's still 10 days of work, right? But it's 20 days of time, and same as P2, T2, and P3, T3. The only task that ends at the same time it was going to is P3, T3 at the end of day 30. But task 1 and task 2 on the first 2 projects, they actually get extended by 15 days to their finish date. So it's again, what if these were in priority? We just pushed it back, because more projects equals more multitasking equals more time for each task to complete, which means a longer schedule. All right? So this is part of what people are adding when they do their own buffer. They're saying, well, I know I'm going to have to do three different jobs during that one time period. And so they do this, right, in their head. And so they say, oh, it's going to take 15, 20 days. But really, if they'd have just done P1, T1, it would have been done in 10 days. So, and then what happens, though, is as you add more, right, my simple example here has 3. But what if we had 5, 10, 20, right? We just keep extending that. We just make it bigger and bigger and bigger. And yes, I'm just using one resource here as an example, but we do this all the time, right? We do this on departments. You know, whatever level you want to think of this as, we're doing this. And it's not bad that we're throwing multiple jobs. You know, I'm not saying we should just do one job, finish it, start and then start thinking about the next one. But in a moment here, we're going to look at some of these other examples of what this really can do for us. So let's talk real quick, critical path, all right? The PMBOK 5 definition, you can read it there, sequence of activities that represents the longest path. So in my layman's definition, it's if a task's finish date changes, that'll change the finish date of the entire project, right? And I'm sure there's other better layman's definitions out there. And we all know that critical path can change. But I just wanted to clarify, that's what critical path is doing. Critical chain is a different level, but I just want to clarify the difference. So now I want to get a little more, before the demo here, get a little more deep into the critical chain and what this really is all about. So critical chain is based on the theory of constraints, and it's about the whole project rather than the individual task, all right? And then straight out of our friend Eli again, we have to identify the constraints. And in our case, for this demos, for this example, we're going to use resources. If you were thinking about this in a manufacturing environment, you would think maybe work centers or even work machines or maybe a resource. In my case here, we're talking about human resource, all right? That's going to be our constraint. And then we exploit that constraint or we subordinate everything to that constraint. And what that means is, if you look at the bottom of the slide here, if task B, let's say there's 2 tasks, right? Task A and task B, and task A feeds B. A is the predecessor to B. So if task B can only produce 10 units a time period, task A either has to slow down or, which is the subordinate, right? Or we have to fix it and get task B to produce more. So it's kind of the same, the same thing with our human resource here. They are only working, 40 hours a week, 32 hours a week, whatever number they're working a week. That's how much they're doing. So it doesn't matter how much multitasking we throw at them. They're just going to increase their buffer because they're not going to increase necessarily. Yes, I know we call it overtime, right? That's one of the concepts too, is that we pay for increased production. It's called overtime. Or if it's physical, we pay to expedite, right? We pay for something to be shipped to us faster. We pay for air freight instead of by a shipping or truck. So that's how we kind of fix it on that side. And then the last thing about the theory of constraints is we elevate that. We figure out what to do and how to fix it, all right? So let's talk about what does critical chain really do? Well, it moves the location of the buffer, which I've been talking about, right? From each task to the project. Now, I said earlier, this isn't for the weak-hearted, right? This has to be a management decision, and trust has to be involved by all the parties, right? This isn't just a couple of project managers and a handful of resources can do this. It has to be an all or nothing, because as soon as you start doing half the plant or half the people do one way, well, that doesn't matter. You still run into constraints on the other folks then. And there has to be this understanding that the buffer is different. So now what we don't want to have happen, and we're going to show this example in a second, but what we don't want to have happen is where people say, okay, I'm not going to tell you it takes 20 days anymore. I'm going to tell you it takes 10, and they're going to trust that management, that project managers are going to look at the system and they're going to figure out where the overages are and fix them, rather than say, well, you said you could do it in 10, do it in 10. Because all we're going to do then is what we just talked about in the last slide. We're going to have to expedite by increasing overtime or doing something else. And if we start doing that, well, the trust is gone, morale will plunge, and this will fail miserably because everyone will start fighting it. And as we talked about earlier, some of the things that we need to have are a resource pool. For this example, I have to have project prioritization. You might need to have resource prioritization, right? Which resource are we going to deal with? And in the demo, we'll show that. And then maybe a task prioritization. It may be an important task on a lower prioritized project. So another thing that scheduling requires, the scheduling requirements, now we're talking, getting into the Microsoft project part, is let's try and make those tasks realistic. And again, we said earlier, but we need to have regular, consistent updates, and we have to have all the projects tracking in the same method. And by that I mean the work type, right? Fixed duration, fixed work, fixed units. It's got to be the same. Otherwise, it's apples and oranges. And unfortunately, it will look like it's apples to apples, but it won't work. Mathematically, it will work, but it won't give us the results we expect. This does work much better with fixed work than it does with fixed duration, but you can use fixed duration. So let's talk about those examples that I've been kind of alluding to a few times here. This is that normal thing we've been talking about, where everybody adds buffer to each and every task, right? And they say that this schedule takes this long. So everybody's incentive is to protect their own time. And then from Eli Goldratt from his book, which is great, a delay in any one step is passed in full to the next step, but an advance in one step is wasted. In other words, if task 2 is done early, there's no incentive for that resource other than, being an honest person to say, hey, I'm done early. But there's no incentive for task 2 person to tell anyone other than hopefully they're doing their regular scheduling updates, but they don't need to rush and say, look, I've got this done early. For example, let's say they finish a task on Tuesday and they have till Friday. If they only do their updates on Friday, we just lost 3 days of work time, right? But there's no incentive for them to get it done early or to tell anyone because they know and we know and everyone knows that task 3 already has buffer built into it. And so we have buffer all along the path. So what happens though, the opposite, what this quote is saying, if task 2 goes late, well, that will directly affect task 3. And then of course the person on task 3 says, see, that's why I add buffer, because you're going to hold me to this time. But let's look in the critical chain scheduling, we say it's in the project. So instead of doing it this way, we come back and we say, okay, task 1 is supposed to only take, let's say, 3 days instead of the 5 or 8 that you're asking for. And task 2, we take the buffer from there and we take it out. But we don't get rid of it, right? This is critical. We don't say, oh, we're just going to cut your time. What we do is we move that buffer to the end. So, visually it might not look perfect, but these are the same amount of time, whether this whole thing is 6 months, 3 months, 1 year, it doesn't matter. These 2 rows are the same amount of time because all we did is we moved that buffer to the project level. So now what we've done is we've incentivized folks to, when they finish on time or early, to just pass it on to the next person. Because and this is why, a couple slides ago, we talked about trust. Because what does management do? They look at that project buffer and they go, oh, great, we can cut all that time out. It's like, no, we can't. What we need to do is find out what's going on and how this project works and how fast can we do it. And as we learn how fast that we really actually can do a project, then we can start cutting out that buffer. But that's the catch, right? Is right now, while we have every task with buffer, we don't really know how fast someone can do it if this was the only thing they were doing, right? That's part of it, is because everyone's giving us a time duration or an amount of work based on all the things they're doing. But if we can get to this spot, the system will work wonderfully for us. And even if we don't get to this spot, the system actually works, and that's what I'm going to show you here in a moment. So as you get better, though, then you can reduce that project buffer more and more, and as you gain more trust. But it's definitely not something you do immediately. You leave that project buffer in there at first. That's a critical point of gaining trust. So again, the longest path, the chain, is now the critical chain of each schedule, and then the resource dependencies of all the schedules. Remember, we're talking about the portfolio here, and then the priority of each schedule against all the schedules, and the priority of all the tasks within all the schedules. So that's the way the system works. So now we're going to get to the demonstration. So for the demonstration, I have 4 named work resources. Tim, Ryan, Jessica, and Colin, they are all enterprise resources off of the server. I'm using Project Server 13 for this. I'm going to do this in Project Pro 13 because it's easy visually to do it all on one screen. But it is using Project Server 13. So, and as I mentioned earlier, you can do this with a shared resource pool locally, so you don't have to have server, but it makes life easier for me anyway. I have standard calendars on these folks. They work Monday through Friday, 8 to 5. They're all 100% available. I only have these 4 schedules on them because I want this to work the way to make it visually easy to see, right? We know in the real world, and that's part of why you want to do this in the real world, is it's much more complex than this. We have more than 4 people. We have multiple types of calendars. And we have more than 4 schedules. So I got real creative. I called my schedules Project A, B, C, and D. These are unique projects. They're not linked together. None of the tasks are linked amongst projects, okay? So it's kind of like that example earlier where, P1, T1, P2, T2. Those were 3 different schedules. This is 4 different schedules. And each schedule has 4 tasks. Not 100% sure why I end up with 4s on everything, but it seems to work out great visually. So, and I put 1 person on each task. I'm using work, but I made them equal. 1 day duration equals 8 hours of work, and each of the schedule tasks, each task has a finish to start predecessor relationship. And we'll see that here in just a second. So now we are ready to do the first of a few demonstrations. So here we have the first demo that I'm going to show with the critical chain. So I have my 4 resources that we just talked about, Tim, Colin, Jessica, and Ryan. I have my 4 projects, Project A, B, C, and D, and I've stuck them all in here on one screen for a visual. I do not have this as a master or anything like that at the moment, but basically all my tasks, all my projects are all the same priority. No work has been done on any of these tasks. So if I'll have to add that column, sorry. I'll add that real fast. So percent complete, you can see 0 all the way. No work has been done. And again, as before, I just have 1 day equals 8 hours. So no interesting or unusual things. And that's the point of this one, because I just want you to see how this works. So the first thing we do is to go up into resource, and I'm just going to hit level all, level the entire project. And when I do, boom, you see what happens. It just took, because they're all the same priority, it basically took them in order, and it moved Tim to the next possible time that Tim could start, to the next possible time Tim could start, to the next possible time. Now, because these were all finished to start, predecessors, logically, the only thing that could happen next was that Colin, Jessica, and Ryan's tasks all moved out, right? So this was the only logical result of a simple 4-way, 4 tasks linked, 4 projects. What happens when they're all equal? So this is what critical chain by resource would do. It would say, okay, we can't have them working overtime. We can't have them working more than 8 hours a day. So what would we have to do if each task was 1 day long? And it would stretch out, and I put this in here on purpose, the total duration went from 4 days to 7 days. So I wanted to highlight that as well. So before the resource leveling, the entire project was 4 days because they're not linked to each other. And then as soon as we leveled, went to critical chain based on resource, it all moved out to 7 days. Okay, so that's the first example where we just had tasks and projects the same priority, no work was done, and overlapping assignments to begin with, which became non-overlapping. All right, this is the second demo. So we're trying to again find the critical chain, but this time what we've done is we've changed the priority. So now we're assuming that for your organization, for the portfolio, you have some sort of prioritization standards, right? The driver analysis, portfolio analysis, and that kind of setup. So once that's set up, and we're just going to make life easy on us here and transfer that to say that translated here to a different priority of each project. So project A is still the same. It's at 500, so it's mid-level. Project B is at 250, C is at 100, and D is at 900. Now remembering that the priority level for each task project is the higher the number, the higher the priority. So in this case, project D is the highest at 900, right? And all the tasks corresponding because they're all equal, because they're all on that one project. And so then A would be next, and then B, and then C, all right? No work has been done, just like last time. The percent complete column is there, but and the assignments are overlapping again. So basically I just reset it, but this time we have different priorities, and that's the critical thing here, right? This is, if you remember one of the early slides, we talked about the fact that we were doing resources. That was what demo 1 was kind of about. But demo 2 here is, look, this is when we have different priorities, not on the resource, but on the projects. So this time, we should get a slightly different result when we hit the Level All button. And visually, you can see it right away. What happens was, last time, if you recall, it had Tim, and then it broke out each, Tim started on one day, and then he started the next day, and then he started the next day. Well, if you look at it, it's the same, right? We have Tim down here now on Project D, but then because of the order, Project A at mid-level priority, which would be the second highest, then we went to the next day for Tim, and then there, and then there. But notice what we did is what happened was the original work for the Tim, Colin, Jessica, and Ryan, the original 4 days for Project D, stayed the same. It moved for all the other projects, right? And if you look at the overall duration, we went from 4 days to 7 days because we had the same original 4 days, which was the multitasking problem. So now we've got the same 7 days, but we totally changed the order of the work, right? We changed which schedule was being worked first. And that becomes pretty important when we're talking about the overall portfolio and which projects have priority. This goes back to that example from earlier about P1, T1, P2, T2, P3, T3. And every time I say P2, T2, I'm thinking I'm saying R2, D2. So I'm not, but it just sounds like it. So if we had different priorities, this would help with that problem, right? Remember, on the PowerPoint we saw on the deck, we saw where the diagram showed that it became, instead of just 30 days, 10 days in a row, we stretched it out. We stretched out each task, remember, because we started them all at the same time. So what this is doing, both this example and the first example, is it's keeping the tasks at the same amount, right? We're saying that we've gotten rid of the buffer, and we're using the time to we're using non-buffer time to determine when the task should happen. So what we're saying is, based on this priority, we're saying, like our example earlier, that project 1, task 1 should start first. And when it's done, then we'll go to the next thing. So that's, in this case, that's project D, task G. So we're saying that's first, and then project A, task A, right? So we're doing that second part. We're saying, okay, without overlapping, based on our priority, based on our resource, when should this work fall? And so we're not worried about, we're not allowing the resource to worry about that buffer. We're adding the buffer, or we're taking care of the buffer ourselves, right? We're basically rescheduling based on the critical chain of when is that resource available. Okay, so now for demo 3, we've taken it up a level. We still have the same 4 resources, the same 4 projects, and just like in demo 2, we have the priorities, right? It goes project D, then A, then B, then C. But we've also added kind of a little more real world to this demo, is that we now have random % completes, okay? And kind of like the real world, I've also got some illogical ones, right? Like I've got this one here, project C, task W at 10%, but the successor at 100%, right? And then at 90%. So, maybe we have an update problem, or maybe we have a bad schedule, but it doesn't matter. My point here is that, look, we know that percentages complete, and again, we're using work, but for the simple example, we're just trying to do some % complete, but I could put it in the % work complete column. But I'm trying to show that this is more realistic, right? We have 4 different projects, 4 different priorities, but we also have different percentages of complete. So I did put everyone back, and I made the % completes work just to make this, the actual start dates work, to make this demo work nicely and visually, right? I'm trying to go for the obvious visual thing here, because when we have real life, we know we don't just have 4 schedules, and we know we don't just have a total of 16 tasks, and we don't just have 4 resources. We have a much more complex real-world environment. So I'm just trying to show how it worked kind of on the simple ones, so that you can extrapolate to how it would work for you. So I'm going to now do the same leveling, and when I level, now look what it did. Wow, it looks messy. And yes, I have split tasks turned on. So you'll notice it split my tasks. It moved things around. It did what it could with the remaining incomplete times. And it did it based on priorities and, of course, what had been done. So you do get some illogic results, some illogical results. If you look at row 12 here, my 10%, notice that because Colin's done on his was 100%, and it started on time just to make my life easy for this demo. You notice that now Jessica and Ryan are dropped there as well. And randomly, Project C is our lowest priority task, our lowest priority schedule, but yet tasks X, Y, and Z are going to be done first by Jessica and Ryan. So this is one of the earlier slides talked about the fact that we need to have regular updates, and we need to have clean or accurate data, because and this hey, there might be a real world situation where this is the correct way, but hopefully if Colin's 100% done on task X and Jessica's 90% done on task Y, hopefully we just have a mistake on task W, and that Tim really is 100% done. Maybe that's a typo, because that would make it fall a little more cleanly, right? But we do have random percentage complete, and you see that the system did what we would hope it would do. It prioritized and it moved people to the right spots based on the resource over allocations, based on the project priorities, right? And we could add task priorities. make it even more complex. But this is, just 4 projects, 4 tasks. So you can see why clean data is important, but what happens here and how it moves things around into realistic time buckets. So and now, again, this is part of that management trust thing of we're moving the buffers around. And you also notice that it moved Project A from 4 to 6.15 days, Project B to almost 7, Project D to almost 6, but it left Project C alone, which again, logically, we would think, well, Project C is going to be the last one done because it's the lowest priority. But the percentage completes move that around. So you need to be thinking about that as well, is how far along are we? And randomly, you might see the overall duration is no longer 7 days. We're going to finish a few minutes earlier than a total of 7 days. Okay, demo 4. So for this 4th demo, I've kind of reset everything back to the way it was at the beginning. The priorities are still, are back to the, everything's the same, right? They're all mid-range. I have nothing done by anybody. And same as before, you'll see we've got the little red man. Everybody's over allocated. Everybody's working the same time. So up till now, though, and we're going to get to the project settings here in the next few slides, but up to now, I've just been hitting the level all, right? And I've been leveling this just everybody. But what if we wanted to level based on just one person? Well, if we did that, we'd come up here into level resources, and we'd pick one resource. In this case, I'm picking Tim. Actually, I need to select everything. Then level resource and just off of Tim. And when I level now, it looks pretty much the same as it did the first time, right? Everything kind of moved. That's because I have such a nice sequential order of tasks and order of projects in the same priority. So what would happen though, if I'd have picked like the second person, Colin, instead of Tim? Look at how that's different. Because we just picked Colin moved out, right, on each of his tasks, and because it's a finish to start relationship, Jessica and Ryan's task moved as well. But look what happened to Tim. No change. He's over allocated, right? And if you see the little red man over here, Tim's still over allocated over here. So this is kind of another way to do it. We can move the whole group of resources, or we can move one single resource. So again, I'll undo that, and then just for grins, what happens if we take the last person in that chain, Ryan? You see, it's the same effect. We just move all of Ryan's tasks out. So, but if you notice, each time I've done this, the overall duration for these 4 schedules keeps going to that same 7 days. It's just where we're moving it. Where's the over allocation, and how we're using it. But all this ties back to the critical chain mindset of, okay, if we leave it as we'd love to have it scheduled at just a day a task, we would say that it's 4 days. But we know everyone's over allocated. So in the real world, everyone's going to say it's taking them 2, 3, 4 days, right? And so what would happen is people would do this by themselves. And each of these individuals would come here and they'd look, and Tim would say, oh, no, it's going to take me 3 days. And because he would be looking at trying to fix his over allocation, right? Because he'd just tell everyone, well, it's 3, 4 days. Whatever, I'm going to do another 4 here to try and move his tasks. But see, Tim would be moving these schedules. But the problem is, so would Colin. Colin would be looking at this and say, I can't do all that stuff the same day. So he would give us the same durations, right? He would increase his durations. He would put his buffer into each of these tasks. I don't want to do this faster. So he would do, let's just say he says 3 for everything. Notice that we're up to 9 days already, and we haven't even asked Jessica and Ryan. And Jessica and Ryan are going to do the same things, right? So basically, we've kind of come around, we've taken out that project buffer, and we said, look, if everyone just did their work when we scheduled it, and we scheduled fairly, and we didn't try to beat people up like we were talking about earlier, we could have all these projects done in 4 days instead of like right now I've got it at 9. But let's just say that every one of these people, Colin, Tim, and Jessica and Ryan, all said 3 days because they're just trying to fix their buffer. Look at that. Now suddenly it's 13 days to get all these schedules done. Right? So and I see that I've got a couple 4 days on Tim. So basically, it's almost a 1-for-1, right? If Jessica's feeling pessimistic and gives us a 5, suddenly she's moving, and it doesn't matter inside of these, but because it's her overall, but she moves each project out, right? And now it's 15 days. We have the same 4 tasks, which we knew we couldn't do it in 4 days because that was the original dream. But by using the critical chain of figuring out which resources could work when, we determined that we could do this in 7 days. And again, I've taken kind of out the buffer to make the demos work. So that's kind of the 4 demos. Now, how am I doing that, right? Which of these options am I using up here, and what am I clicking on? So that's what we're going to go back to the deck to look at, and I'll cover these options of how we did this. And of course, I just covered already this resource 1, selecting a single resource. Okay, so back to the deck here. This is just for those of you watching this live. If you're watching this on the recording, you could pause any other point. But this is just a quick recap. Demonstration 1, all the tasks and projects were the same. No work was done. It looked like this. And then when we hit the button, because it moved everybody out and it didn't worry about priority, it just shifted everything to 7 days. Number 2, we had the different priorities. No work was done. It looked the same, as demo 1 at the beginning, but this time we have those priorities. And then you can see it changed all those dates, which I didn't highlight in the demo part, but it's on the screenshot here because the point was the visual, right? So, and then on demo 3, same priorities, except we had some random work done. And when we did that, it split the task, moved things around. And then demo 4, we showed the leveling 1 resource at a time, right? And then I went in and also clicked on, what happens if every one of these had some buffer 3, 4, or 5 days, right? So where did this come from? How did the system do that? Well, the good news is a lot of this is straight out of the box. There wasn't much changing or modifying, but it is something you have to think about. So in the ribbon for resource leveling, the first thing that I changed it to manual. Then I looked for over allocations on a day-by-day basis. And that's critical because in my example, I had all these people Monday through Thursday, right? I only had 4 tasks. If I'd had done looking for over allocations on a weekly basis, well, that wouldn't have moved anything because they were all on days, right? I intentionally overlapped them by day. Tim had 4 tasks on 4 projects assigned on that one day, but in that week he only had those same 4, right? So this is a critical option as well. Is what are you looking for over allocations on? Is it a daily thing or a weekly thing? And I can see a very strong argument for it being a weekly thing, especially if you're updating weekly. And in our case, the critical chain would absolutely not have been affected if we'd done week by week, right? So you want to think about this, and this goes to how you're scheduling and what leveling, what degree of scheduling you're doing, to what level of tasks, right? Are they short term, longer term, whatever? Then the leveling range, I just picked the entire project. Now the leveling order we're going to get to here in just a second. I'm going to dive into this in a little bit more detail and these different sections here. So On the over allocations, there's that part I was just talking about, the week by week, day by day. Of course, the other side too is if you're doing hours or minutes, you're scheduling at a very deep level, and good for you. That's some tough stuff that you're doing there. All right. So the leveling order, that's kind of the next big part, because there's three options here: ID only, standard, or priority and standard. And there, that's straight out of the help, the Microsoft Project Help. Again, I'm using 2013, but the ID only one would be a little strange to me, because you'd have to enter, it's based on the order that you enter the task, which may or may not be the right way to do it or think about it. But that's kind of one of those options that if you're picking that, then you know what you've done to make that the requirement for yourself. Normal folks use the standard. I was using standard for all this, even though I also use project priority, right? Because you see, the standard one, it considers slack or buffer, lag leads. It considers the dependencies, the priorities, and then the constraints. So I didn't have any slack. I did have finish to start dependencies on every single task. And then on demos 2 and 3, I had priorities, right? I had different project priorities. And then, of course, within that, my tasks by definition were the same. But and then constraints. And if you remember earlier, I mentioned the constraints would just mess it all up. Could mess it all up, because you have constraints, which you saw, like in our example, we had a nice clean 4-day spread, right? And then when it pushes, well, what would have happened to like, let's say it was Tim, Colin, Jessica, Ryan. So what would have happened if there was a start no sooner than or a start no later than, either one, on a Jessica task? Well, that would have split things even worse, right? And moved things around even more. Especially, let's say that was on Project C with the third highest priority. So you can see, again, constraints can be quite affecting to the critical chain. And then the priority and standard is just like standard, except it uses task priority first. So you could have, kind of think of it as, you could have a project with a very low priority. I think in our example we had Project C, which was the 100, but you could have a task on that project which is a 1,000, right? The most critical task of all. So it would actually take that task and make it the number one thing to do first, even though it's on a lower project priority. So, and some of this is just best done by testing it a couple times and seeing what happens. So the next part of that box is the resource leveling options, that bottom half. All right. So I've got, again, we just talked about the leveling order, but then here's again, out of the Microsoft Help Desk options, the Microsoft descriptions of what each of those tasks, checkboxes do. So, and again, which ones you have checked can dramatically affect how the resource leveling works and how the critical chain comes out, right? So I obviously had mine checked to where we can create splits. We saw that was part of what I wanted to show. I don't have any proposed booking types on mine, but we could have had a proposed schedule. We could add, Project E with proposal tasks on it. And then think about how complex you can make this. You could have a high task priority that's proposed, right? Think of how that would affect this. All these different settings affect how these things work. And then the level manually scheduled tasks. I don't have any manually scheduled tasks on mine, but I do have it checked. I intentionally take off the level only within available Slack, just because, well, of course, in this example, I didn't have any Slack, any buffer, but I tend to not like how the result is when I do that within the Slack. However, again, you might want to test this and see for yourself if you like the way that the Slack option works for you. So that is my presentation, and here is my contact information. So you can reach me by email, I am on Twitter, or on LinkedIn. So I want to thank you for your time and your attention, and please let me know if you have any questions or comments or thoughts that you'd like to share with me or that I can help you with. Thanks.